We're pretty much live. Hello, everyone. So, welcome to our another JackBD sessions. Today, we have a great speaker, Pratik Patel. We're gonna, talk about data science. The idea is when we talk about data science, or when we say the term data science, we think it's Python, but there is another world where we do data science without Python. We do in JVM and we all know JVM is one of the performant things out there. And when things gets a little bit serious, we need performance, and performance is pretty much synonymous to JVM platform, right? So we are basically going to talk about that today. But before that, let us know from where you are joining and say hi. What you were doing, why you were interested. We have a chat sections where you were watching. So type your comments and in whatever you want to say, uh, and we'll go from there. So Pratik, how are you doing?
I'm doing great. Thanks. Thanks for having me. I'm looking forward to this session. Should be some fun. So,
We are all looking forward to have some fun, and we want to learn things, how we do things in JVM worlds. And I'm sure our audience will be you know really happy to see how we can do things on JVM, because we love Java, we love JVM platforms, and we want to do this sort of works in JVM.
that's
Okay.
right. That's right.
Yeah, that's really interesting, and I'm really looking forward to learn from things from these sessions. So yeah, let me see if there anything we have from the audience yet. If not, we're gonna jump start now. So I'm gonna
Okay, let's do it.
share my share your screen. You can either do the full screen, or the way it is now.
Yep,
Either way is fine.
I got it. Let's do this. Oh, let's just do this. For now, I'm just gonna share in a window, and there we
Okay.
go. All right. Thank you so much. Um, we'll go and get started. So, as mentioned, this is a session on data science on the JVM. And Basil said that we're Java developers, so we can do Python, but it's more fun to do it in Java for us, right? So that's what we're going to talk about here. And along the way, we'll talk about some of the libraries which are available in the Java universe, or let's say the JVM universe for doing data science um, on the JVM. And it does. The truth is the libraries available in the data science universe are a little bit behind for Java compared to Python, but there's still quite a bit that you can do. And the libraries are getting updated and starting to get up to parity very quickly, which is nice. The other thing that I think a lot of people miss when we talk about data science and which platform we build data science solutions on is that people are already doing a lot of the data science type of work on the JVM today. We have such great tools in the big data universe that run on Java. For example, Apache Spark, Apache Kafka, I consider to be part of data science as well, in some ways, right? And then there's also Cassandra, which is used to hold huge amounts of volumes of data. So there's already quite a bit of stuff in the Java universe that underlies what people do in data science. So we'll talk a little bit about that as we move forward. But let's get into this. My name is Pratik Patel. I'm a Java champion. I also am a board member for the Atlanta Java User Group, which is one of the largest Java user groups in the world. And out of that nonprofit, we also run a event called Dev Nexus, which will be in April of 2022 in person. We're really looking forward to getting everybody back together because the Dev Nexus 2020 event was the last in-person Java event before COVID shut everything down. So, anyways, if you want to make a trip to Atlanta and see us in April, the weather will be nice. Come and join us. And let's skip past that. One thing I want to mention is I work for a company called Azul Systems. And we think we make the best JVM in the galaxy. We have a high performance JVM as well as open source JDK builds, which is very, very popular. So the open source JDK builds or the builds based on open source OpenJDK are available for free and anybody can use them. And in fact, in this demo today, I'm going to be using Azul Zulu, which is our OpenJDK build, to run Apache Zeppelin, which is the data science tool that we're going to work on today. And Azul Platform Prime is our high performance JDK, which if you're doing anything at scale, whether it's a Spring Boot application or you're running Apache Kafka or Apache Spark or any of the other data science tools we're going to talk about today, it's a great tool to use. You can get 20% performance gains out of the box with pauseless garbage collection, which is really nice. And of course, since we're just changing to JDK, you don't have to make any code changes. And with Platform Prime, you get more stability, you get better throughput, and of course, you can save money on your cloud infrastructure, which is really nice because everybody knows that cloud is not cheap, right? So, all right, so let's get into it. Let's talk about Apache Zeppelin first. This is the primary tool that we're going to use today to demo everything. And it's a really nice tool for doing what I like to call prototyping and also exploratory data science type of work. You can obviously build production apps on it too. I like to think of Apache Zeppelin as a super REPL, right? Everybody's worked with the REPL, REPL, read, evaluate, print loop, whether you're doing it in something like JBang or you use other programming platforms which have a nice REPL. I like to think of Zeppelin as a super REPL in some case. But at its core, what Apache Zeppelin is, it is a web notebook like Jupyter Notebook. Right? So you'll see as we go through this, it's very similar to Jupyter, except it's built on Java, and it has tons of connectors for all of the big data projects I mentioned previously, which we'll look at while we're going through this. Right? And if you're not familiar with REPL or a web notebook like Jupyter, what it does is it allows for interactive type of development. And that's what, in my opinion, makes this a lot of fun. You can build out something in an interactive way, and you can see as you're building things what's happening, and you get like that kind of immediate feedback, which is really nice. And we're going to do a demo of that so you get a chance to look at it. And of course, Apache Zeppelin, like Jupyter Notebook, is just accessed through a web browser. Okay, and I have Apache Zeppelin running locally, but of course you can go and run this in the cloud, and there's the possibility of also having user accounts, so you can have multiple people using the same Apache Zeppelin instance and working on different notebooks or even the same notebook, depending on how you want to do things. All right, so without further ado, let's hope that our demos work well, but we're going to just jump straight into a demo right now. All right, so let's go to our Zeppelin instance. I'm going to increase the font on this a little bit so that everyone can see it a little bit better. Let's make it a little bit bigger, right? So you get a good view of it.
Yep, we can see it now, I guess.
Okay, good. Hopefully the font is a little bit more readable now. I just bumped it up a bit. So this is an Apache Zeppelin notebook. Let's actually start at the beginning here and go to a slightly different place in a Zeppelin notebook. What I'm going to do is going to just start at the kind of landing page for a Zeppelin notebook, right? So there's a bunch of tutorials that we have here already built into Zeppelin. And what I'm going to do is I'm just going to go look at some of the tutorials that are here. We're going to work through this Kotlin Data Science Basics tutorial. This code and this notebook is available on my GitHub repository, which I'll share during this presentation. So you can just pull this down and you can actually play with this exact thing that we're going to run with today. So hopefully you'll do that after the session. And if you have any questions, you can reach out to me on Twitter by direct message, and I'm happy to answer any questions. But let's go into our notebook and let's do some basics first. Okay, so what we do for each paragraph inside of our notebook is we tell Zeppelin what is running in this paragraph. In this case, we're saying this is going to be a Kotlin paragraph, right? So we can write some Kotlin here if we wanted to, which we've done in the next stanza here. right? So each one of these little sections is called a paragraph, and we can go run each paragraph by clicking this button, and that's going to run very quickly, of course, because it doesn't do anything. But let's scroll down and have a look at this other paragraph here. All right, so I'm going to say, and this is not specifically Java. You can write in Java with Zeppelin. You can also write in Scala, but these code examples I've done in Kotlin, because Kotlin is a little bit easier to work with when you're building out stuff in a script style instead of just building classes and stuff like that. Again, you can write Java, but it's a little bit more interesting, in my opinion, to write this kind of stuff using a script type language like Kotlin. So you can see I've declared a function here, which, as you can guess, it's just doing a square. And then on the next line, I'm using some Kotlin string interpolation, and I've created a list underneath that. So let's just go run this real quick. And let's go change this, actually. Let's see what happens, okay? So you can see I ran this previously. I'm going to go run this again. Instead of taking the square of 5, we'll take the square of 10. So this 25 should change to 100, and then we'll get a different result here. So I'm just going to scroll up here, go run that, and you can see that it's now running, and our code is run, and we get the output here, right? So all I did was a print line to print that stuff up, and I don't have to click this button. I can just hit, let's go change this to 1,000, or I don't know. Let's just make up a number and say Pratik, and I'll hit Shift Enter, and that will go run. And you can see it's went and run that paragraph. And apparently the square of 33 is 1,089. I didn't know that, but there you go. Okay. Also, one thing that's kind of useful here is at the very end, I just have an L here, which translates to this list. Well, let's change that. Let's make this a little bit better variable. I saw our friend Venkat Subramaniam, who most of you probably know, who's spoken at Bangladesh Jog, he tweeted something yesterday where he said that don't use single letter variable names because, as everybody knows, one of the hardest problems in computer science is naming things. So don't use single letter variables. So I'm going to change this from L to list based on his suggestion. And what this does is if you just have a variable printed like this, obviously you can see that I've created this list value here. But if you just put something here like this, what Zeppelin will do is it'll say, oh, you just want to see what that thing is. So you can go and do that, right? So we could also go and do that, for example, for this greeter, which is, again, just a string or an interpolated string. So if we go run that now, you'll see that we get a couple of different things here. And for this list, you'll see that it's printed that it's telling us it's a string, which is a unit, and it's of type Kotlin.string, which is kind of nice. You can just go and print something out like that and see like exactly what that is in terms of what kind of object is underneath there. Okay, and since we're running in Kotlin, what we can also do is print out a whole bunch of the different things that are available. It looks like we have a whole bunch of different variables inside of our context already, right? So you might be wondering, where is this train data to and this data frame and all these other different things coming from? So one thing to note that when you are running in a Zeppelin notebook, everything that's in this specific notebook, even though it's in different paragraphs, is running inside of the same context. So I've already run this notebook just to make sure that all of the code was running properly before I came and gave this demo this morning. And so things that I've declared below this line will show up as being in context. So we'll talk about this training data 2 variable that's here, which is of type data frame, and it's 300 rows and 16 columns wide, et cetera, et cetera. Right, we'll get to that in just a minute. But I just wanted to explain that quickly so you can get an idea of what's going on here. Okay, so I'm going to go run this again, clean that up a bit. Now, if you're into Apache Spark, or if you're looking at Spark, and if you're not familiar with Spark, Spark is a in-memory data transformation and processing engine, of course, for Java and for Scala. And you can also do it in Kotlin, right? So there's a plugin for Apache Zeppelin called Spark Kotlin, which allows you to go and actually run against a Spark engine that you can connect to, that you might be running locally, or you might be running it somewhere in the cloud or wherever. Okay, you can go and configure that. So let's take a quick aside while we're here and go and have a look at some of the settings for this very quickly. All right, so what I did is I clicked up on the top right and I went to Interpreter. And the way that Zeppelin works is it's a modular design where you have different types of interpreters and plugins that you can use within your Zeppelin environment. So let's go over here and let's go look at the Kotlin interpreter real quick. Okay. So, oh, that went and found that. Let's actually do this. Sorry, I searched on the wrong thing. I want to search here under interpreter. So there's our Kotlin interpreter. And there's some permissions you can set and some properties, number of max results and stuff like that. But one thing that we are interested in here is you can see that we're going to use this library called Krangle to do some data manipulation and transformation in a few minutes. So how do we go and set these external artifacts for our project? Well, what I would do is in the Kotlin interpreter, and again, if you're using the Spark interpreter, you go into the Spark interpreter, or the Java interpreter, you can set it there as well. But what I did is I said, I want to edit it. And then you go down to dependencies. And here we have artifact. And what I've done is I basically have put in the Maven artifact name and the version number. So when you want to pull in artifacts, what you do is you go and you click edit on the interpreter right here. We're in the Kotlin interpreter right here. And then you basically just go put in the Maven repository name for that specific thing. Now, one thing to note here is that let's go and see how we can set different repositories, because obviously not everything will be in Maven Central. Maybe you have an internal repository where you want to pull stuff into your Apache Zeppelin project. So I can click on repositories button on the top right. And then you could see that this is Maven Central, which is a default. And then there's obviously local repository here. You could see it references my .m2 repository folder. And I've also included JCenter because that's where the Krangle API or library is coming from. So we can click this plus button here, and then we can go add our own repository, which is pretty nice, right? So I just went in and added JCenter because that is where that specific library called Krangle, which is something we're going to use in a few minutes, lives. Okay, but by default, Maven Central is here. So if we click on that, you'll see that it says repo1.maven.org, and then of course local, and I added my own repository. But the point here is that you can go add in whatever repository you want. It could be an internal company repository, or it could be a public repository like JCenter or whatever. Okay, now let's get back to our notebook that we were working on. Let's do some more code examples. Okay, let's scroll down here a bit. We talked about Spark. And now what we're going to do is we're going to start with our example here for a bit. And since I'm running this locally, and since I have my files that I'm going to import in to do some data manipulation on, what I've done just to demonstrate something very quickly to you is I've said, okay, this is where I have all my data sets. And then I'm just going to say, and this is a file object, which points to a directory. So then I'm just going to say data root, go and list all the files, and then for each, print each one of them. So let's see what's in this directory, right? So you can see that I have a test.csv, et cetera, and we're going to pull one of these in, basically the training data.csv, and we're going to import that into this Apache Zeppelin notebook, into the specific context that's running behind it. And again, if you remember, the way that Apache Zeppelin works is that it is modular, it has different plugins, and we are specifically here running in the Kotlin context, which will be unique for this specific notebook. So we're going to load it into this notebook. Okay. All right. So let's go load our training data. We'll say, well, you're going to use the data frame type, which is built into Zeppelin. We're going to say read a CSV, and we're going to load in this training data. There's 1,000 data points in here, but we don't want to load all of them for this demo. We're going to say for all the training data, go and get a sample of 0.3 of those. So this will load essentially about 300 different things in it. So you can see right here that I'm printing the training data's head, and then I also want to see what the schema looks like. So I ran that previously, and you can see what that looks like. It said we loaded data frame with 300 rows in it, and this is the structure of the data, and these are some of the different things in it. It has an ID, a vendor ID, pickup date time, drop off date time, et cetera, et cetera. What's the latitude and longitude of this specific data that's here? Okay, and a bunch of other things. How long was that trip? And if you haven't figured it out, this data set is an open data set that you can grab, which is on New York City taxi trip durations. So it has data for taxi trips, where it started with latitude and longitude, where it ended, how long was the trip, et cetera, et cetera. So that's the data set that we're going to be working with this morning. All right, so let's scroll down a bit. And how do we access a data frame? So we've loaded up this stuff into this variable called train data. Again, that's up here. Let's scroll up a bit. All right, so we said this is all our training data. Go and read that in. But for what we're going to work with today, just take a sample of 300, or basically 1/3 of that data set, which had 1,000. So we'll get approximately 300 of these, since we said 0.03. And we put that into a variable called train data, right? Or training data. All right, and what I've done here is I've just printed out a few things, or how we access a data frame. So we can say, training data, go and get me the passenger count. Training data, give me the trip duration, etc. So let's comment this out actually. Let's clean this up and let's go rerun this. Okay, so if we run that, you'll see these are our trip durations. And if I comment this out, other line out, say what the passenger count was, it will give us everything in that column, not the row. We're accessing the column in this case. Okay, we could obviously also get the data by a row. So a data frame is basically like a table. Okay, so you can see that for these trips, the passenger count was one person, two persons, five persons, etc. All right. So let's move on and let's start doing something interesting with our training data now. All right. So the first thing I want to do to make this a little bit more sane is that rather than using the actual string that references each column, I've just created a variable like vendor ID, pickup date time. It just matches the specific string that represents that column in that data frame, so that I don't make some kind of spelling mistake and mess things up, right? It's a little bit of defensive programming. So I've just created these variables that represent all of the different columns in that CSV file, which has been imported into train data or training data variable. Right, pretty straightforward stuff so far, as you can guess. And now just to test that out here, you can see I said, instead of having quotes around it, training data passenger count. If I go run that, you'll see what happens there. And now what I'm going to do is I'm going to go and print the schema that we can generate from that data frame, because I don't want to type all this stuff out. I would rather just print it out and just copy and paste it later, which is what we're going to do. So I'm going to say train data, print the data class schema that is represented by that data frame. So when I run that, you can see it actually writes out some Kotlin for me that says data class, right? We're going to call it taxi rides. And here are all of our different columns that we have inside of this new data class that we're going to generate from our data frame. Okay, so and then what we're going to do is we're going to say create a new variable called records, use the data frame and create all the rows as this data type that we just defined above, which was taxi rides. So we generated this data, or sorry, this data class using this print data class schema. So it generated using the data frame as the basis, as the schema, and we created a new class called taxi rides, which is a Kotlin data class. And if you are familiar, you can also go and think about this as records. You know, records was introduced in Java 14, and it's pretty cool stuff in the Java universe. And Kotlin already had something called a data class, which is very similar to records in Java. So anyways, we're doing these demos in Kotlin again because we want to work in more of a scripting style rather than building out classes and stuff like that to get that interactive style of development, right? I love Java, but I also like Kotlin. Kotlin can be fun to do stuff like this in. All right, so now that we've created our data structure and put everything in a strongly typed way, right? And that's one of the reasons why we love Java and why we love Kotlin is because we have that strong typing that helps us to build programs, in my opinion, faster and with less errors. And you get IDE tooling that helps you along the way and all those kinds of great things. Okay. All right, so here's my data class that we just copied and pasted from above after we generated it from our data frame schema. And we're going to say records, training data, create all the rows from that training data and use taxi rides as the type or the class that underlines that. Right, so when we go and do that, we can say, here's the record. So I'm just going to say records.take1. So that will print out the first one. So here's our record, right? And you can see that our data has indeed been transferred from that data frame kind of loose, non-typed format to a strongly typed data class called taxi rides, which has typing for all those different things. Because if you look at this data class, you'll see, for example, that the pickup latitude is a double. And then we also have the pickup date time as a string currently. Well, that's a little bit of a problem. If you want to do some manipulation with the date time here or do some calculation, we can't do it as a string. So what we'll need to do is we'll need to convert this from a string into a strongly typed data type, right? So that's what we're going to do on the next line here, right? So what I've done here is I've just said print line, go and give me the first pickup date time, right? So that's this right here. So that's what the pickup date time looks like. 2016, April 9th, 9 a.m., et cetera, okay? And so now that I know what that looks like, we're going to use the standard datetime formatter, and we'll say the pattern is, just as we saw, year, month, day, hour, minute, second, and that's our date pattern. And now we're just going to test parsing this. We're going to say local datetime dot parse this date and use this date pattern, right? So we went and got the string out of there, and then we just printed it out to make sure that everything looks good. So now we have our routine for converting those dates, which are currently represented as strings, into date time so that we could do some calculation, or we can use it for doing some calculation. All right, so let's go do that now. All right, so here's our training data as before. Here's our datetime pattern, and we just went and made sure that that was all okay first. What happened there? Let's not do that. So now what we're going to do is, instead of overriding the existing column in our training data, I'm going to say training data, let's add a column, and we'll call it pickup date time. And we're essentially just going to iterate over the data here in a map and say local date time, parse that, use the date pattern, and basically go and take a column that already exists, add a new column, and we're going to map over the existing column that will go and allow us to convert it from a string into a date time object that we can use later. Okay, so that's what this line does here. We're using simple mapping to do all that kind of stuff. Okay, all right, so let's go and do one more thing, and this is a little bit more advanced. The next thing we want to do is, in terms of data transformation and data processing, is we want to see how far each trip was. Now, we know what the starting latitude and longitude are, okay? And we know what the ending latitude and longitude are also. So what I did is I found this very useful answer on Stack Overflow, which is, how do you convert latitude or longitude to meters? Right. So I didn't come up with this. I just found it. I was like, oh, this looks good. I basically rewrote it from Java into Kotlin so that I could do this calculation using the starting latitude and longitude and the ending latitude and longitude for each trip to determine how far that trip was. Now, of course, when you're a data scientist and you're doing stuff like this, you're like, oh yeah, this is fine. This will give us the distance between point A and point B. But in fact, this is not quite right. Right? Can you guess why this is not the exact correct way of doing this? I'll give you a second to think about it. I'm sure most of you have come up with the answer already. And the yeah. So do you want to take a guess, Buzzler?
Is that because the trip doesn't really go straight, rather than we take routes, different routes?
That's absolutely right. Right, especially when you're in New York City, you're not. What we say in English is what we're doing is we're calculating this as the bird flies, right? Like over the air. But you're in a taxi, so you're obviously not flying in the air. So uh, this is one thing that we have to keep in mind when we do this, because of course, if you've ever been to any major city, not just New York City, of course, you never go directly, right? You're gonna go down 7th Avenue, and then you make a left on 39th Street, and then you make a right over here, and then you got to go all the way around to get through the tunnel to get to the airport, blah blah blah, right? But anyways, for the purposes of this demonstration, what we'll do is we'll just use, as they say, the distance as the bird flies, right? But again, if you're a real data scientist, you would need more data to calculate exactly how long this trip was, because in any city, you're never flying in the air. You're taking roads, you're making turns, you're going around, and blah, blah, blah. Okay. So now we have this function called coordinate distance. And this is what we will use to calculate the distance in meters as the bird flies. So let's scroll down a little bit. And we're going to say, go and add a new column, right? We're going to have that be distance in this case. And against our original data set, we're going to run a map now. Okay, and again, if you're not familiar with Kotlin, you probably recognize this as being a lambda in Java, right? Very similar syntax. And we're going to invoke our coordinate distance function here. And we're going to pass it the pickup latitude, longitude, and the drop off latitude, longitude. We're going to pass it into our coordinate distance function. It's going to map over all of the rows in our training data set, right? So that's our thing right here, as you can see. And just one second, I'm just going to double check something. All right, so that is going to, again, create a new column. So we've created 2 new columns in this data set, right? Let me scroll back a little bit and remind you of the previous one that we created. The previous one we created was we wanted to add the pickup date time to this specific data set because we had it as a string and we want it as a date time object so that we can do some time calculation, okay? And so here we go. We've added our coordinates, and then we're going to add some extra columns here to do some more stuff also, which is the month, weekday, hour, work, etc. Right? So we're adding some extra columns here on top of this. So we're going and basically massaging our data and converting our data to useful format. All right. So now let's go have a look at what this looks like. Our new training data, which we call training data 2. Okay. So now if I scroll down here a bit, let me move this up. It's a bit difficult to do on a big screen, but you can see now that we have this distance column added into here. And you can see that this trip was 5,832 meters. This trip was 2,319 meters, et cetera, right? So you can see that some of the trips were short. 1,500 meters is approximately 1.2 miles or 1 mile or something like that. This trip was very short, 527 meters or half a kilometer. It looks like someone didn't want to walk in the rain or whatever, right? So now we have this data in here, so we know what's going on in terms of that. Okay, so we have our distance already. All right, so now let's work with this a little bit and let's see what we can do. All right, so we have our data again in this train data 2. This is our data structure we created where we added some extra stuff, and using this data frame object, we can go or using, sorry, not data frame, but using this object, we could say, go and just give me the distance and the trip duration now, because that's what we care about. Okay. So you can see now we're printing out the distance and the trip duration, and it is in this columnar format here. Okay, so let's just scroll back to just a second. All right, let's go have a look really quickly. Hang on just a second. Let me make sure I show this in the right place. All right, so there we go. We have all this stuff in here now. Just want to double check that everything looked good before we run the rest of this program. All right, scroll down. We've done all this stuff. Okay, the trip duration was provided for us already, but we could calculate it ourselves if we needed to. And now what we're going to do is we're going to do something a little bit different now. So we have training data, select, we selected those two, that's great. Now we're going to run a filter against this data and say, filter for trip duration less than 1,000 seconds, right? So now we will only get our trip durations, what is that, minutes or seconds? I think that's in minutes actually, right? So now we will only get our trip durations, which were less than 1,000. Well, actually, 1,000 minutes doesn't make sense because that's a lot of minutes, right? 1,000 minutes would be 16 hours. So that's right. This data set, so 1,000 minutes is actually in, 1,000 seconds is trips, which are basically less than a half an hour. Okay. So we have this data now. And what we're going to do is we're going to calculate the speed. Now that we have the distance and the amount of time that these trips took, let's go add a new column for speed. So we'll say to this data structure, train data 2, add a column, call speed, and you can guess how we calculate speed here, right? And it is in seconds. You can see I have 3.6 here. So we say for each one of those rows, it, right? So if you're not familiar with the way Kotlin does lambdas, it is an implicit a keyword built in, which represents each row as you're going through a data set like this. We say for each distance, it divide by it.trip duration multiplied by 3.6, and that will give us the speed in kilometers per hour. And then we can go and print that out. We could say we created this new data structure that added that new column. We'll say select the distance, the trip duration, and the speed. And now you can see for these trips, and I didn't filter anything here, what the speed was. And of course, this is in New York City. So you can imagine the speed is not very high. If you're in the middle of the night, you might be able to go 30 miles an hour through New York City from point A to point B, but typically you're going pretty slow. You can see 9 miles, sorry, not miles, kilometers an hour, right? 9 kilometers an hour, 20 kilometers an hour, 10 kilometers an hour. And this trip was very slow, 3 kilometers an hour. Okay. So they must have gone during rush hour. All right. So now let's say, well, let's see what the slowest to the fastest speed was. So now what we could say is sort by speed. So here's a new data structure where we added the speed column. We'll say sorted by the speed column and then by distance. Okay. So if we go here, you'll see that now we've sorted this by speed from low to high, and we just printed it out again by using this select that's here, right? So pretty good stuff. All right, now this is where things get more interesting with Zeppelin. Now what we can do is we can actually go and visualize this. So the way that we'll do this is we'll say print line percent table. That lets Zeppelin know that we're going to produce a table now. And then let's go and print the distance, and then we'll put a tab here, the trip duration, and the speed, right? So that basically is a hint to Kotlin to let it know that this is the data that we're going to send it and how we want it annotated. And so now we say sorted by speed for each row, print out the distance for that row, and we use a T to separate out the next data point, row trip duration, and then row speed. And so that will go and print everything out for us. And if we go look, scroll down a bit, I'm going to make this a little bit smaller so it fits more onto my screen and onto yours. Uh-oh, not that small. Okay. Okay, so now that we have that, we can go and look at this data in various different ways. Okay, let's right, you can see here the available fields right here. And that's interesting because if you remember right here, that is where we said these are the different fields or the properties that we're going to put into this table. So now let's go and look at this in a different way. Okay, let's do this as a line chart. Okay, and actually let's get rid of the settings, right? And you can see now that we have this nice graph that is produced in terms of how fast the trips were and how long they took and stuff like that. And we can go and manipulate these in a few different ways to get a better idea. Of course, this is not going to be very helpful as a pie chart, but I think maybe a bar chart may work best for something like this. There you go. Okay, so what we did is we got some data, we imported it from a CSV file, we created a strongly typed data structure using a data class, and then we added some columns. We did some calculations, so we extrapolated or we did some data extrapolation by the data that was already there. We created a couple of different ways to, we added the distance, we calculated the distance, the trip duration was already there. We went and we did some filtering and some sorting, and now we can go and play with these different types of things. So this is pretty nice. There are lots of different things you can do with this, of course. And one of the interesting things here is you can click here and you can say, you know what, I actually want this data now that I went and manipulated and processed and massaged, and I want to go and export it to a comma separated or tab separated file. Maybe you want to send it to your business analyst or your business person, whoever, and you can go give it to them. Or what you could do is you could just point them to this Zeppelin notebook, and then they can just click on this button and get it themselves. Right? That would be fun too. So, anyways, let's scroll down a little bit, and we're almost at the end of our demo. We're going to get back to talking about Zeppelin a bit later, but right, so you can see we printed the data, the passenger data here, and there's other stuff that I was working on here, which not quite yet. I was trying to use a different plotting engine for Zeppelin, but not quite finished with that yet. But that's basically our entire code demo so far. Okay, so we could go and add more other stuff to this. Actually, let's just try this. All right, we're gonna live dangerously this morning. Let's go and sort this. I don't want to sort this by. Let's go and add a new one here. Let's say I'm going to create a new thing. Let's say sorted by distance. Do we want to sort by distance? Yeah, let's try it. Let's say sort by distance, and then we'll just go do this. Okay, and then I'm just going to copy this quickly. Oops, don't want to do that. Okay, there we go. And all right, let's see what happens if we do this. Let's go run this really quickly. And okay, so now this is sorted by distance from high to low or low to high. And let's take this sorted by distance now. And instead of sorting by speed here, let's change this to be sorted by distance. Let's change this graph. So let's get a little bit more of a line graph here. And let's go rerun this. Let's see what this looks like now. Okay, there it goes. And actually it looks very similar because it looks like there's a strong correlation between distance and the amount of time it took. So yeah, there you go. I was going to actually try to create a completely separate graph, but I don't want to spend too much time on this because I want to get back to the slides and give you a little bit more insight into Zeppelin itself. So we've run the demo. So let's do a little bit of a quick review and talk about some of the libraries we used here, right? So first of all, again, you can think of Apache Zeppelin as a super REPL because you can save and share this notebook. And again, this notebook is available on my GitHub repository. I have a link to that at the ending slide here. So you can just pull that in, and I'll give you a couple of other tips that you'll need to be successful in running this at this point, right? And when we run Kotlin in Zeppelin, it is an interpreter. It runs Kotlin as a script in the context of Zeppelin. Each notebook is a separate context, so you can have multiple notebooks doing different things, and they don't collide over each other. But each each notebook itself is a single context, so it has state within the notebook is the best way to put it. Okay, once you run it, of course, right? So a persistent state is persistent within the notebook, and we start each stanza that we want to do Kotlin in with %Kotlin. There's lots of other things that we could do. If we wanted to use Spark in Kotlin, then we would start it with Spark %Spark.Kotlin. And actually, let's take a quick aside. Real quick and go in and see how we would actually configure this to connect to a Spark interpreter. Okay, so let's go into here. So take a second to load. Let's say we want to look at Spark, right? So this is the Spark interpreter. And again, the way that we use a Spark interpreter is we preface it with %Spark, and then, or even in Kotlin, we could use this Kotlin one is already hooked in Spark. And if we scroll down a little bit here, you can see this is where we would configure where our Spark interpreter lives. And the default is just connect to the local Spark interpreter, or sorry, not interpreter, the Spark runtime, i.e. our Spark instance, which has all of our data in it. And you can see it will connect to Spark on port 7077 locally. And there's a whole bunch of different names that, or properties we could specify here. But again, the way that we did that is we came here under the top right where the settings are, we went to interpreter, and we scroll down to the Spark interpreter. And while we're here, actually, let's do one more thing. Let's look at a couple of other interpreters that are available here. Okay, there's if you need to do some front end stuff a little bit more fancy than what's available, you have access to the underlying as Angular. There's Apache Beam. You can also connect to a Cassandra database to pull data in from Cassandra. That would be really fun, right? So there's where you could set some properties. You could connect into Elasticsearch if you have Elasticsearch. You could have, we don't want to talk about Flink too much. Flink is a great project. If you wanted to, you could write this in Groovy for those of you who are Groovy fans. Right, you can connect to Hazelcast, Ignite, but let's get, here's the Java interpreter right here, right? So if you don't want to write this in Kotlin, you can write it all in Java, no problem. But this is a fun one right here. You can actually just connect to any JDBC data source. So if you're running like, MySQL or Postgres or whatever, you can actually just go connect directly into a JDBC data source. And if you look down here, you'll see this is how you specify which database. In this case, it's just defaulted to the local Postgres database that's there. And then you can actually just query a database and produce graphs from a database directly from within your Apache Zeppelin notebook, right? That sounds like it'd be pretty cool to do. There's a Kotlin interpreter. I don't want to go through all these. I just wanted to highlight a few of them, which are interesting. You could also write in Markdown if you wanted to like make this part documentation, part notebook, MongoDB, Neo4j. You can even run Python within this, right? So if you feel like, oh, I really need to use NumPy or Scikit or something like that to do what I want, you could actually write an Apache Zeppelin notebook paragraph which uses Python, which is really cool, right? So you have options to do all those different types of things, which is a lot of fun. If you need to execute a shell script, you can do that too. All right, so loads of possibilities. Like I said, I love prototyping with this when working on data projects or big data projects or data science projects because you have so many different options and everything is very pluggable. So let me do this for a second. There's some questions in the chat. Let me see what some of the questions are. So Brandon says, Zeppelin notebook be available to review after the presentation. Yep, Brandon, we will make the notebook available for everybody after the presentation. You can go download it. I'm going to talk about a couple of caveats in terms of being able to load this notebook successfully. There's a little bit of a bug there that we need to talk about. The other question from a LinkedIn user looks similar to Jupyter Notebook. Absolutely right. It is like a Jupyter Notebook. What is the benefit to use static language for data analysis instead of dynamic language? Okay. So this is a great question. And without getting too deep into it, One way that I do some of this stuff sometimes is I'll actually, if the code is very complex, I will actually go and write the code inside of IntelliJ IDEA or something like that, right? Basically like a modern IDE. And I'm just going to try to find a quick demo project I have for this. Let me see where it is. I have a Kotlin project where I base some of this data science stuff on.
So while you are looking for it, let me
Yeah.
ask the audience. It is time for asking questions. Whatever questions you have, it doesn't have to be, Sometimes we don't ask questions, right? We feel feel like to something going on our mind, but we don't express it. So it is the time to ask your questions. It can be anything. Don't hesitate. Just ask your questions, and we'll try our best to answer your questions within the scope, of course. So feel free to ask any questions you have regarding this today's presentation, even data science in general. I'm sure our speaker Pratik
Yep.
is going to
Happy to answer
you know
questions.
yes. So now is the time for utilize that power.
Yeah. So this is just very quickly what I want to show, for example, is that I would possibly pull up something like this. If I have complex code, whether it's in Java or in Scala or in Kotlin, I would write it out like using a IDE, so I get all my tooltips and I get my completion, and all the benefits of writing in a strongly typed language, and then I could move the code over once I'm happy with it into my Zeppelin notebook, so that I can essentially go and execute it. So let's go back to our notebook really quickly. Right, so we talked about that. My computer's running very slowly now. I have too much stuff open. So let's go get this
Sure.
back. But yeah, so that's for me, I like both dynamic languages and I like statically typed or strongly typed languages. But when I'm building something for real, I like to have the safety net of a strongly typed language, not just for the safety net part, but also when I'm running inside of a modern IDE like IntelliJ IDEA, I get all the great things, the completion and the hints and all that kind of stuff, so that I can write the code faster, especially when the code is complex. So okay, so a couple of good questions come in. What would be the alternative of Scikit, Learn, or similar in Kotlin? Okay, so this is a great question. Let me defer that question for a couple of minutes. I have a slide on that. And then the next question was, is the notebook code interoperable between JVM languages? The short answer is yes, it is actually. Because what you can do is, because everything is just running within a single Java runtime and interpreter, there is the possibility of interop. Okay, so we'll talk a little bit more about that, I think, in a second, but we'll talk about this scikit-learn in just a minute too. Okay, so data science in Kotlin. Of course, everyone knows that Java and the JVM and Kotlin are much faster than Python. So when you're processing a large amount of data, Java is a great option because of the 25 plus years of engineering that's got into the Java virtual machine, which makes it very, very fast for doing data processing, right? And of course, when we're working in Kotlin, we get type safety, we have lambdas, and of course the JVM is there, right? So someone was asking about libraries. What are some corollaries to like NumPy and Scikit and those other libraries which are available in Python? So, for example, there's something called Kotlin Statistics, which is a nice library for doing stats inside of the JVM. Okay, so Kotlin Stats. There's also something called Kmath, which is very similar to NumPy in the way that you use it, which is pretty cool. Okay, and then there's Kotlin Spark. It's Spark with the Kotlin flavor. And the library that we used in here to do some of the data manipulation that you saw was actually Krangle. So if I flip back to my notebook, I kind of glossed over this a little bit, but you probably noticed that there's this import statement right here that says import Krangle. So Krangle is a thing that has some of these nice low-level libraries for doing some of the things that we did here, right? So let me just pull up Krangle real quick. Let's go to their webpage. hopefully it finds it, right? So this is what it's called. Krangle is a Kotlin library for, let me scroll down. Kotlin library for data wrangling. The filters, transforms, and reshaping tabular data is what we saw here. So if I just scroll down to some of the features, right? So we did the filtering, we did the transformations, all those different things. Very, very similar to working with Pandas, which is a very, very popular library in the Python space. And let me just take a quick aside here and say, well, why can't we just do this with like just straight Kotlin or straight Java? You can, but one of the reasons why Python, okay, let me rephrase that. I would say that the primary reason why Python is so popular with data scientists and people who do machine learning and stuff like that is not so much because of Python, but more because of libraries like Pandas, libraries like NumPy, because these are higher level libraries that allow you to very quickly work with data, transform data, process data, calculate data, manipulate data, right? So it makes it much nicer to work at that higher level where you have these tools that say, oh, just filter this data set for me, or go and add a column to this data frame, right? So you saw how we coded it. It was very straightforward. It was intuitive, which was really nice, right? So that's why these libraries are popular, and that's why people like to use them. It makes the job of the data engineer or the data scientist much easier. You can get from point A to completing your feature very quickly. Okay, and then of course, since we're running on the JVM, there's all sorts of different libraries that we could use. For example, if you're into deep learning or machine learning, there's deep learning for Java, there's Smile, there's core NLP or natural language processing. So yeah, so let's have a look at a couple of questions. Um, someone asks, Golang is very popular. Comparing Golang, how efficient and rich is Kotlin for data science? I will unfortunately have to pass on that question. I am familiar with Go. I have written stuff with Go, but I am not familiar with the data engineering and data processing and data science libraries in Go. So that is a question I cannot answer because I have not looked at that in any detail. Um, the next question was from Amit is, assume I'm loading a CSV of size 100 gigabytes. Will a computer with limited memory be able to load and process the data? So this is a great question, Amit. The short answer is probably not, because you're just going to blow past the heap on your JVM. But let me give you an option, right? What you would do in that case is, I'm just going to flip to my back to my my Jupyter notebook here real quick, right? And here's where we loaded our data, right? Well, actually, let me go find where we loaded our data, right? So what I would do in this case, if you're loading something that's like 100 gig in size, that's very large, of course, right? So what you would want to do in this case is, you don't want to load all the data all at once within here. What I would do is something like this. I'm just going to write some pseudocode, right? So I would not necessarily read this all at once like it is here. What I would do is I'd probably do all training data dot dot each, and then I would say something like it, and then I have my Spark.Kotlin context here, and again, this is just pseudocode. And then I would say, I'm trying to remember what the exact command is. Add row into by Spark context. We would need to give it name of Spark. It's not called a database. It's called, trying to remember now. This is off the top of my head. So name of Spark, not instance, but I think it's called a space. I don't know, right? So what you do is then I would go and add each row one by one into a Spark instance and let Spark hold that in memory. So what you would need to do is you would need to configure an Apache Spark instance, sorry, not an instance. You would actually need a cluster, because yeah, you could scale a JVM to have, 100 gigabytes. A Spark JVM instance that has 100 gigabytes of space in it, but typically for something like that, you would split that into, let's say, 10 different Spark instances as part of the same Spark cluster with 10 gigabytes each, and then let Spark go and essentially spread that data out over the cluster so that you can do parallel processing against it. Okay, so that's the way I would do it. And the other thing is, I don't know if I would actually load up that much data from within a Zeppelin notebook. What I would probably do instead is I would probably write a either a Apache Spark Scala or Apache Spark Kotlin or Apache Spark Java program that went and did this as its own separate process. And then I would come back to Apache Zeppelin, and then I would connect up my Zeppelin instance to that. Let's just load this up so you can actually go and see it, right? So this is how it would work. Actually, I had an example of this. I totally forgot I did. This is one of the core examples, actually, that comes with Apache Zeppelin. So you can see, let me make this a little bit bigger so you can see how this works. Spark context, parallelize, right? It's going and pulling in this massive CSV data set. We create a class that represents that data set, and then transferring everything to a data frame. But you can see what this is doing is that this is doing everything within a Spark context, and it's actually going and loading stuff up directly into a Spark backend, just like that. And again, the way that I got to this, right, you can see there's a nice graph here that shows that data set loaded into Spark. The way I got here is, when you load up Apache Zeppelin and you go to Notebook, it will be under the Spark tutorial section, and there's loads of great tutorials here for working with Spark as well. You can see that the Spark SQL is actually really nice too. You do have to write Scala for this specific one, but let's scroll down a little bit. Right, you can see that they're going and loading in some sequences, and this is what the data looks like. Let's keep scrolling, and there's read it in data frame, and there's somewhere in here where they actually show a nice graph. Where is that? Probably towards the bottom, but let's see if it's here or not. Right, here we go. So this is where there's, oh, that didn't show for some reason. That's weird. Let's see if there's another one here. Oh, here we go. Right. So here's using Spark SQL, for example. Spark SQL is a way of querying a Spark backend using a SQL-like syntax. So you can see here's the SQL-like syntax, and here's the data that was outputted. And there's some more examples here that you can go and check out. So it's pretty interesting stuff. Okay, so that's that specific question. Let's see what the next one was. Yes, you want to load the data into Spark, as you say. Yeah, and Amit also said, shouldn't the JVM be able to optimize the data processing at runtime much better than a dynamic language like Python? And yes, Amit, you are 100% correct. The Java Virtual Machine has probably the most advanced just-in-time code path optimizer available on the planet. So when we talk about JVM, when we talk about things going fast and working at lightning speed, that is the JVM. Absolutely. All right. Can Zeppelin be used for low latency, high volume data processing and data engineering pipeline and create data sets by post-processing and EDA on Zeppelin? So the short answer is that yes, you can do this in Zeppelin. But I would say that if you're really looking at low latency and high volumes, you want to do let's say you want to do your experimentation and prototyping in Zeppelin, and then you want to take that code and put it into a project that you can just run as a separate process so that you don't have the overhead of Zeppelin, and that you can run it as a batch script, or you can run it continually or whatever. Okay, so that's a great question. But I think of Zeppelin more for doing experimentation, doing prototyping, getting everything working and being able to visualize things and working very quickly. And then I would take that code, and in your specific use case where you want it to be low latency and a high volume of data, you may want to think about mixing Apache Kafka into this architecture, where you can then use event streaming to process it along with Apache Spark. A lot of people use Kafka to feed data into Apache Spark, for example, which is a perfectly valid and good use case for it. So, all right, just a couple more slides here near the end. Right, so I don't want to go on a rant about Scala. Scala is a great language, but there are some nice libraries like Krangle, which we briefly mentioned before. We already done a demo of Krangle, so I won't do it again. But remember, there's loads of interpreters in Apache Zeppelin. There's Spark, there's Markdown. You can even do JDBC. You can connect to a Hadoop data store with the HDFS plugin, et cetera, right? And we use the Kotlin one. We talked about Apache Spark already. It's a distributed processing engine that you can connect to a local small instance or even a production massive instance from within Zeppelin. So you have a lot of options here. We talked a little bit about the different contexts that allow you to connect to these different types of things also. And that's basically it. Okay, so there's a couple of things I want to reference really quickly as we wind this up. The first thing is that to make this work properly, I had to go and create a new version of the I had to go and hack the Kotlin interpreter for Apache Zeppelin to support newer features of Kotlin, specifically some features that Krangle needed, which is like basically the dynamic creation of classes at runtime in newer versions of Kotlin. So I have a special jar that you have to plug in for this. So let me go into here and I'll just show you where that's at really quickly, right? So what you'll do is you'll grab this jar file for my Google Drive link, and then you go into Interpreter, and then you go into Kotlin, and then you'll just basically drop in this jar file, which I've already created for you, that has a fix for running newer Kotlin libraries like Krangle that require dynamic compilation. Probably the shortest way to put it. All right, so you'll need this. I'll post the link to this also. And then, of course, for the actual demo code, that is on my GitHub. Let's go pull that up. github.com/Pratik Patel. All right, so this is my repository, and it is in, be able to find it pretty easy, right? So Kotlin Data Science Basics. So if you go into here, here's the Zeppelin notebook that you can pull in. There is also, it also has a link to the jar file here. So I'll go ahead and post it into the chat so that all of you can see it and you have reference to it. So there it is, right? So there's a link to the jar file here, where you should put it. And one thing to note is that when you import this, you may need to go in and double check this part. I found a little bit of a bug here, which is kind of annoying, is that you need to make sure that the Kotlin is set to the default interpreter. So let me scroll to the bottom real quick. I believe that's where it is, right? So right here, at the very bottom of this, when you import this, or for example, well, I found out the hard way that like with this, you can take a notebook like this that already exists, right? And you can import it directly, or you can clone it or whatever. But you do need to make sure for these examples to work properly that this default interpreter group that's at the very bottom of the notebook that you're interpreting is set to Kotlin. Otherwise, you'll get some strange errors. You'll be like, I don't know why this is working. Pratik was doing it and it was fine. But just be aware of that, okay? So here's the GitHub repo. It's got the jar file, and you have the notebook is here that you can directly import. It's pretty easy to import a notebook. You basically just go here to notebook, and then create new note, and then you can say, oh, that's not it. Where's the import function? That's weird. I've done this before. I don't know where. Let me go back. Oh, it's on the top page. Sorry, right here at the main page. It's import notebook, and then you give it a name, and then you can just add it directly from the URL. But if you do this again, remember that you have to go in. You'll have to shut down Zeppelin. You'll have to go in, and you'll have to go into the after you've imported it. Basically, shut Zeppelin down, and then go all the way to the bottom, and ensure that this says Kotlin as the default interpreter group. Otherwise, things won't work. Okay. All right, so that's the end of the presentation, everybody. If you have more questions, let's see if there's some more questions, Basler. Okay, yeah, I think I don't see any more questions, so that's great.
All right. Thank you very much, Pratik. It was really great presentation, and the demo was really great. I'll personally look into this, and I have learned a lot from you this presentation, and I'm
Thank you.
sure our audience also learned a lot of interesting things. And we can proudly say we can do data science on JVMs without think.
That's right.
Yeah, I mean, those who love JVM language, they usually want to do things over here. So and when
Yep.
we see that data science is on in other language, it feels sometimes a little bit you understand the feelings, I guess.
Yeah,
So
absolutely. Yeah, I like programming in all different kinds of languages. Um, you know, Java is my favorite. Of course, I'm a Java champion. I've been doing Java for a long time, but I've done stuff in Python before. And Python's a great language, but I never have been able to get used to the fact that Python has white space aware, right? If like in Java, if you have just random white space, it doesn't mean anything. But in Python, you have to have exactly the right amount of white space to denote different, basically, what would you call it in Java? Different scope inside of your code, right? And I always find that to be very, um, very, just I just never could get my head around that because I always worked with, before I worked with Perl and with C and like, white space doesn't matter. And when I did start doing Python, I always would get a little frustrated. Oh, I didn't put enough spaces there. So that's why this program. Right. Not to say that's a bad language. Python's a great language, but I love me some Java. And for me, more than anything else, when I'm doing data engineering, especially, and data engineering basically means working with data at a low level to do processing and manipulation and get it ready for the data scientists or the data science work you're doing. I just love the speed of the Java runtime. Like I can load up gigabytes and gigabytes of data and throw it into a Spark cluster, and it just processes it so fast. So really nice to be able to do that.
yeah, and the other thing is, we are used to with the strongly typed language, and we want
Yes,
to have that type safety, and we want our ID to help while we're writing code. So silly mistakes.
that's right. That's right.
So
Yeah.
we don't. Yeah. So those are helpful, definitely. And so from this presentation, I'm sure is so there is opportunity to learn and do things on JVM, and you are going to get all these benefits of JVMs and plus the data science, you if you want to explore this path. So obviously it's definitely refreshing, and I loved it, and I'm sure our audience also appreciate it, and some of them already mentioned in the chat that they
Yep.
really like the presentations, and I couldn't thank more. I really appreciate having for having you, and you spend the
Thank you.
almost 15 minutes, I guess, 1 hour and
Yeah,
15
yeah, no
minutes. That's
problem.
a lot of time,
I,
and
I, I could keep going for another hour. I can do more demos and stuff, but we'll let everybody get back to their Saturday, right?
all right. So thank you everyone for who watch, who participated in this presentation, and I'm sure you were able to take so many valuable lessons from these presentations. And thanks, Pratik, again. Um,
No problem. It was wonderful.
we'll
I had a
we'll
great time.
any last minute uh, la- last thing you want to say to our audience, anything?
Oh yeah. So the last thing is you can my Twitter handle is at Pratik Patel. You're welcome to reach out to me via Twitter DM if you have some follow up questions or if you run into a problem or if you want to learn some more about Azul stuff. Again, I work at Azul Systems and we make different JVMs. Our JVMs are designed to work very well with different types of big data and high throughput processing situations, whether you're using Apache Kafka or Apache Spark, or you have a really big Spring Boot monolith. You should check that out. So, yeah. So again, happy to help on your journey to learning some of this stuff. Welcome to reach out anytime over Twitter. So, and thanks again for having me, Basil. This was a lot of fun.
Thank you. We also enjoyed the presentations and demos. All right, guys. Thanks all. We'll definitely have another sessions pretty soon. We don't and we'll keep doing these sort of sessions, and let us know how you like it, and if you want to have any ideas that you want to have sessions with, please reach out to us, and we'll try to rearrange that. So thank you everyone. So we'll end here.